Hello everyone. In the next series of videos, I will be covering the LC3 instruction set, which is encompassed by these following 14 instructions. I will give a brief description of each instruction and break it down into the micro instructions involved in each of these, following the fetch and decode phase. Let's begin with the add instruction. In the assembler, the add instruction has a given format where the first and second parameters are the destination register and one of the source registers. The third argument can be either another source register or a 5-bit sign extended binary number. This instruction will add the contents from the first source register and the second operand from a register or a given decimal value and stores this output into the indicated destination register. The machine language encoding for this instruction uses the 5th bit to determine the difference between the addition of two registers versus the addition of a single register and a 5-bit sign extended binary number. This 5th bit, as you can see here, is a control signal to the SR2 mux, which determines the second operand that enters the arithmetic logic unit where the actual addition process is carried out. Next, we will cover the AND instruction. Similar to the add instruction, this operation in assembly language is in the same format where the first parameter is the destination register and the second one is one of the source registers. The third argument is the second operand to this operation, which is again either another register or a 5-bit sign extended binary number. As you may know, this instruction does a bitwise AND of the contents in the source register with the second operand, be it a register or a binary number, and stores the output into the indicated destination register. And as before, the machine language encoding uses the 5th bit, which is the control signal for the SR2 mux, to choose the second operands. The only difference between this and the add instruction is that the ALUK control signal will now force the ALU to AND the inputs instead of add them. Another simple yet important instruction implemented in the LC3 is the NOT instruction. This instruction requires only a destination register and a source register. The operation committed here is a complete bitwise complement of the source register that is stored in the user-indicated destination register. In the LC3, the ALUK control bits, as you can see here, pointed by the arrow, will be set to complement the contents coming out of source register 1, and the output from the ALU will be stored in the destination register. Now, looking back at the 3 instructions we just covered, it is important to note a key trait of these 3 operations. All of them, after completing their operations, set something known as the condition codes in the LC3. These condition codes are 3 bits denoted by N, Z, and P in the LC3 data path, where N stands for negative, Z stands for 0, and P for positive. At the end of the operations, these condition codes are set to reflect the magnitude of the output when it is considered as a 2's complement binary number. This brings me to the last instruction we will discuss in this video, the conditional branch. This instruction is used to branch to different addresses in memory depending on the current state of the condition codes. In assembly programming, this instruction is used with something known as labels, which is what you see here. As of now, all you need to know about these labels is that they are variables that hold a target memory address. It is also important to note that not all instructions from the LC3's ISA set the condition codes after its completion. Excluding the 3 that we have discussed here, there are 4 more instructions that set the condition codes. That is, load, load indirect, load base plus offset, and load effective address. These are the instructions that we will cover in the next video. Thank you.